Very few people fully understand the dangers of their household electrical system, and an alarming number of people don't know how to avoid situations that could lead to fire or electrocution. Have you ever had an electrical shock? Of course you have. I say that because in my 26 years of teaching this subject, I've only found a couple of people that claim never to have had a shock. Did you know that even the smallest detectable shock could kill you if the conditions are right? Most people have been shocked in the past with no ill effects, leading them to assume that it takes a large electrical shock to kill a person. That assumption is incorrect. It takes as little as 6/1000ths of 1 amp of current to kill you if it crosses your heart. The fact is, death by electrocution is usually due more to bad timing than to the amount of electricity you touch. Think about that. The next shock you get might be the last one you ever get. My advice? Don't mess with live current. When you work around electricity, it's extremely important to know what you're doing. There are some obvious ways to avoid shocks. First and foremost, always shut off the breaker or pull the fuse supplying any electrical device you intend to work with. When using a ladder to do electrical work, you should always use wood or fiberglass because these materials are less conductive than metal. You never know when you might accidentally contact a live wire in a circuit that's not been shut off. Manufacturers make a variety of great circuit testers in a variety of price ranges. When used correctly, these testers will keep you from making a fatal mistake. Let's look at a couple of items that can help protect you. This simple neon bulb tester is so inexpensive that there's no excuse for not having a tester on hand when you do electrical work. It can test both 120 volt and 240 volt circuits. All you have to do is place one probe on what you think is the hot side of a device or on a wire, and then place the other side on something that's connected to ground. If the bulb lights up, live current is going through the wires. Then there's this plug-in tester, which is one of the best things you can own if you work with receptacles, because it tells you a lot more than whether or not you have current in the device. It can also tell you if the wires are correctly attached to the receptacle. If the wires aren't correctly attached, the tester will tell you what the problem is. All of this for under $10 is certainly worth it. One of my favorite testers is this low-cost combination continuity circuit tester and pocket screwdriver. It can tell you if a switch is working correctly without putting power to it. It uses your body like a wire to send a tiny amount of harmless current supplied by batteries in the device through your body and through a device like a switch. If the tester lights up, you have a good path for the electricity to flow. And when you hook up the switch to 120 volts, it should work just fine. If you want to test for live current, you stick the metal tip of the screwdriver against something you think is live, such as a slot in this extension cord, while keeping your finger on the metal tab on the side of the device. If you have 120 volts in the device, the tester will light up. If you stick the tip into the side of the device that is grounded, also called the neutral side, you will still get a light, but it will be slightly dimmer than the 120 volt side. You can also check the grounding hole. It should give the same light intensity as the neutral or grounded conductor side of the cord. If it doesn't, the ground connection is bad. At prices higher than $10, you can get into more sophisticated equipment such as this Gardner Bender Circuit Alert Tester that will light up and make noise like this if you even get close to electrical current. This device is also available built into a multi-purpose tool like this one that's handy for a number of other electrical tasks. With all the great testing tools available at your store, there's just no excuse for touching a live wire and getting a potentially lethal shock. Besides working with live current that could kill you, what other hidden dangers await a person who decides to do their own wiring? For starters, failure to properly strip wires can be hazardous. The proper way to strip wires is to first measure the proper amount of insulation to remove. There are a number of ways to do this without using a tape measure. Since this is such an important step, manufacturers build measuring gauges into many of their devices. One example is this receptacle. If you look opposite the grounding screw on the back, you'll notice a recessed compartment with an arrow. You put the wire in that compartment, mark the proper spot with your thumb, and then remove that amount of insulation. You can remove the insulation using the built-in stripper on the device like this. Another method would be to use a tool such as this one, which is made to do the job professionally. Notice the built-in measuring gauge on the tool. You mark the proper length, which is the length of the sharp cutting blade, put the wire into the appropriate size hole, squeeze gently until you feel a cutting edge touch the wire, then push off the insulation with your thumb while tightly gripping the wire with the rest of your hand. Another important precaution when working on electrical projects is putting the proper hook on a wire before you connect the wire to a device. The proper hook should leave the tip of the wire even with the point at which the insulation was cut off. You do not want any insulation under the screw because that could lead to a bad connection or worse, a loose wire which could cause an electrical fire. After you properly strip a wire, there are a number of clever ways to make a perfect hook. On receptacles, there's a plastic hook that you insert the stripped wire under, then bend the wire around the screw while the hook holds it. On good wire strippers, the manufacturer puts two holes, one on either side of the cutting blade, that you can use to properly bend the wire. If you're right-handed, you use the hole on the left of the cutting blade. If you're left-handed, you use the hole on the right of the blade. Hold the tool flat and bend the wire to make a perfect loop. Another very important safety measure is proper grounding. So let's look at a couple of ways to properly connect grounding wires. If there's more than one bare grounding wire in a box, electrical codes state that you must connect them all together and also connect them to any grounded device in the box. Here's how you do that. We're going to pretend that these wires are the wires inside the box. Cross one grounding wire, the left one, over the top of the right one. Pinch them together with your thumb and forefinger where they cross, then twist them clockwise about 8 times, like this. If you keep the wires spread almost opposite each other, you'll end up with a very tight twist. Next, cut off one of the two wires, preferably the shorter of the two, leaving one long wire sticking up. Once you twist the wires, there are two common ways to lock the wires together so they won't come apart. The first method is to use a Gardner Bender green guard wire nut. This nut is only used for grounding. Notice that it's green, which is the standard color used to indicate that it involves a safety grounding wire and not a wire that conducts current. It's the only nut with a hole in the end which allows you to place it over the end of the wire and twist it onto the wires you just twisted together. The second popular method of securing twisted grounding wires is to put this device called a crimp sleeve on them. You use a crimping tool to squeeze the crimp sleeve so that it will tightly hold the wires together. The last electrical safety issue we'll address here is making sure that you do not accidentally allow a white neutral wire or a bare grounding wire to contact the hot side of an electrical device, or allow a wire nut to accidentally loosen and come off. The best way to keep these dangerous situations from happening is to use electrical tape. When you install an electrical device, such as a receptacle, wrap electrical tape around the device to cover the conductor screws. This insulates the screws from anything they might contact that would cause a short circuit, which could start a fire. When you install wire nuts, wrap electrical tape around the nut and down onto the wires to make sure the nut will not loosen and come off. All of the safety precautions we've talked about here are very important, but the most critical one of all is shutting off the power before working on any electrical project. If there's no current running through the wires, there's no risk of getting shocked.